This time with the Unimat SL, I'll be cleaning all the disassembled parts and stripping down the finer mechanisms.
Welcome to Adventures with a Very Small Lathe.
The quickest way to get metal parts really clean is in an ultrasonic cleaner, and I've decided to try out this carburetor cleaning fluid that should be able to dissolve the most stubborn grime. The fluid is supposed to be diluted with water and is intended to work hot, but my tiny ultrasonic cleaner doesn't have a heater, so I mix the solution with boiling water. To make things less messy, I keep the parts in a glass jar to make it easier to move them in and out of the cleaner. The ultrasound can easily pass through the glass without the effectiveness being reduced too much. For the dirtier parts, I brush them down to remove loose grime to avoid wasting the capacity of the solution to dissolve oil and grease. The less dirt it has to dissolve, the longer the solution stays effective. To transmit the ultrasound to the jar, there needs to be a layer of water in the bottom of the ultrasonic cleaner tank. To keep the jar from cooling down, I use boiling water for this too. Ultrasonic cleaning works by agitating the dirt on the surface of the metal, causing it to break up and dissolve. It's effective at dislodging hard or abrasive particles which may have become embedded in the metal or lodged in hard-to-reach places. The solution acts as a solvent to carry the dirt away once it's been dislodged. Ultrasonic waves are sounds with a frequency too high to be heard by human ears. Domestic ultrasonic cleaners use waves between 20 and 40 kHz which cause cavitation of the metal's surface. This cavitation makes the dirt dissolve much more easily. Ultrasonic cleaning fluid can contain ingredients that dissolve dirt as well as ingredients to increase cavitation. Most fluids are formulated to be most effective at warmer temperatures, so larger cleaners also contain a heater. A better ultrasonic cleaner is on the shopping list as soon as I have a proper workshop again. While the cleaner is running and the parts soaking, I'll take a look at some of the larger parts. The saddle is unsurprisingly one of the dirtiest parts. It's caked in a mixture of dried oil and grease along with swarf and dirt. I used a wire brush to dislodge the loose surface dirt to avoid any damage to the alloy and remaining paint on the underside.
Swarf has even got embedded in the underside of the saddle casting, and it looks like a really long time since this has been cleaned. I didn't put the fixed toolpost into the cleaner because I couldn't get the screws to come out, but it doesn't seem to have much dirt to remove. The screws look like they don't come out because the tips have bulged due to being tightened many times to hold tools in place. To replace them, I'll have to cut them off as they won't back out without damaging the threaded holes. Robin Renzetti has suggested solving this problem by using hardened screws, which aren't soft enough to deform, but that's probably overkill for this little lathe. The small parts have been in the ultrasonic for a full cycle now, so let's see how they're doing. A brush clears the loosened dirt, which is still stuck to them. The cross-side rails are really important for the lathe to work well. They need to be clean and smooth for good operation and undamaged to ensure precision. The paint on this part has been almost completely stripped by the cleaning process and the solution. It didn't occur to me that the solution would be this aggressive, but this is a lesson learned. The part is the underside of the tailstock and it's made of die-cast Samac alloy, so it doesn't need paint to prevent corrosion. I'll remove the remnants of the paint and leave it at that, but I'd like to avoid damage to the rest of the painted parts, so I won't be using this solution on any of them. This is the cross slide, which was also painted. This part is steel though, and the solution doesn't seem to have been nearly as effective at stripping the paint. It has damaged the paint beyond repair though, so I may have to strip it completely. The aluminium handles seem to have cleaned up okay, though there are some small patches of discoloration that feel smooth to the touch. The cross-side lead screw still has dirt in the threads, so needs quite a bit of scrubbing. I'm putting all the parts back into the jar as I go through them, and they'll all go back for another cycle in the machine. This wheel is missing the handle, which is going to make it much more clumsy to use. I'll make a replacement as an early project. This is the headstock clamping screw. As it's been under the headstock, it was very filthy, just like the lead screw. There are a few rough feeling spots on the second cross-slide rail which might be corrosion. I'll take a closer look once I've finished with the ultrasonic. The rest of the parts are mostly small fasteners which are not too dirty and not worth individual scrubbing, so I'll put them back into the jar and start another cycle. While that's running, let's take a closer look at the painted parts. The paint on the Zamac alloy is only left in a few isolated spots in the corners. It comes off pretty easily, but it's going to take a while to get it perfect. I'll leave it in the solution to see if that makes it easier. The paint surface of the steel cross-slide block is ruined, but the paint itself is pretty firmly stuck to the metal. I can scratch the bulk of it off with my thumbnail, but there's still a base layer stuck to the metal. I doubt the solution will be much help to strip it completely, but I'll leave it in the tub until I'm ready to look at it properly. Before handling any clean parts, I need to get rid of all this mess from the cleaning solution and start with a clean surface. Most of the parts are ferrous, so getting rid of water quickly and after cleaning is vital. I use blue tissue to soak up any water clinging to the outer surface first, then lay them out separately for the next step. Ultrasonic cleaning solutions contain ingredients that reduce the risk of corrosion, but it's still not a good idea to leave the solution on the parts once they're cleaned. Once I've wiped down all the larger parts, the smaller parts can be shaken and scrunched in the tissue all together to remove a lot of the moisture. WD-40 was originally formulated as a water displacer, so it's extremely effective at getting into nooks and crannies and getting rid of any remaining moisture. As an added advantage, it then leaves an oily film all over the parts, which will keep them protected against corrosion. The parts need to be turned over to make sure they get reasonably covered. These parts are all done, so they go off to one side. To get the remains of the damaged paint off the steel cross-slide block, I'm going to use this water-based gel paint stripper. It takes a good thick layer to work well, and it only keeps working as long as it stays moist. For really stubborn paint, it can help to wrap the whole thing in cling film to stop the gel from drying out. After about half an hour, a brush should be able to clear off the softened paint. This paint is a bit more resilient than usual, so it took a couple more coats, which I won't bother to include here. Now it's time to look at the larger parts. The saddle casting is one of the most difficult parts to clean, as it has lots of inaccessible nooks and crannies where dirt is built up. I want to keep what's left of the paint, so I'm not going to soak it in the solution which I know would damage it, so I'm using WD-40 to dissolve the grime. Once I have a proper shop again, I'll invest in a 5 litre tub of unpressurised WD-40, so I can soak parts in it to clean them. For now I'll make do with the aerosol. I got this set of pipe cleaning brushes especially for cleaning this lathe, as it has so many hard to reach round holes to get into. For the more stubborn surface dirt, I use the brass wire brush, but with caution as I know it will wear down the paint. The most stubborn dried-on oil has built up around the slideways, presumably from many years of oiling. Where the oil and grease is thickest, a Scotch-Brite pad is useful for cleaning it, but I use the pad sparingly as it can easily damage the paint and scratch the metal. Somehow the deep cavities on the bottom have got chips packed into them, and it's pretty difficult to get out. The final challenge is the greasy mess that has got packed into the horizontal split in the casting. The bigger pipe brush is gradually shifting it away, but it's really filthy and getting everywhere as it comes out. Once it's all clear, a wipe down with a cotton rag gets things looking nicer. Cleaning out the bores effectively will help make sure the saddle runs smoothly and accurately on the bedway rails. This is one of the most critical moving parts on a lathe, so it's worth some attention. I'm going to clean the bed the same way. These grooves align the bed rails, so getting them clean will make sure the rails are aligned correctly so the saddle moves straight and true. The brass brush can't get quite deep enough to shift the dried oil, but the pipe brush seems to work great. The large hole is the main alignment for the headstock, so another important surface for cleaning. Having a good range of different pipe brush sizes is really useful for making sure I can clean all the holes effectively. The tail end looks as though it's been lubricated frequently and the oil has built up around it. For the large open area between the head and tail, light rubbing with Scotch-Brite seems to clean the surface up nicely. The bed rails are a really important part of the lathe to get right, for similar reasons and in similar ways to the cross-slide rails. They need to be free of dirt to make sure the saddle runs smoothly, and they need to be true and parallel to make sure the saddle runs straight and aligned with the spindle axis. Whatever I need to do to remove the dirt, it mustn't be something heavily abrasive, which might cause the surface shape to be changed, even a tiny, hard-to-measure way. I'm using Scotch-Brite very gently without any pressure on the surface, which seems to be both effective and non-damaging. Initially it's hard to tell what discoloration is caused by, but most seems to dissolve leaving clean steel. There are some much tougher spots which look like they're due to corrosion, and I'm not going to try and remove them with abrasives yet. The rail mounting holes need to be cleaned to make sure the bolts sit securely and are holding the rails in the right place. Dirt in the countersink could cause the rail to be pushed slightly to one side or twisted. As well as cleaning up the remaining dirt, wiping down with a cloth ensures a consistent oil film all over the rail. The second rail cleaned up pretty much the same way as the first, with a few spots of corrosion to be dealt with later. This lock nut, which secures the feed handle, was left in place to keep track of where it came from, but now it needs to come out for cleaning. Just like the cross-side screw, the lead screw needs quite a bit of brushing to get into every turn of the thread. Fortunately, it looks like it's been kept well lubricated, so the oil hasn't dried on and there's no sign of rust. There are signs of some thread damage at the end which sits directly under the chuck. Once I've brushed along the entire thread, Scotch-Brite helps clear any dirt and brighten up the steel. A final wipe with a cloth, and the lead screw is looking good. The headstock looks most heavily caked on the side facing the drive pulley. This is unsurprising, as this side will be facing any splashes of cutting oil or other dirt when the lathe is working. These two screws tighten the headstock casting around the spindle to lock it in place and need to come out completely for cleaning. As I clean the casting, it's important to make sure I don't damage the lining of the bore, as it's responsible for holding the spindle straight and true. Like the bed rails, the bore needs to be very clean to allow the spindle to move smoothly to enable one of the most interesting features of the Unimat SL. Unlike most lathes, the spindle can be advanced forward and retracted back while the lathe is running. It's controlled by a handle pinion in this hole here, and if the spindle needs to be held firmly, it's clamped with screws in these two holes at the back. The pipe cleaning brushes are ideal for cleaning out the pinion hole and the locking screw holes. The flat surface and notched pin on the underside need to be cleaned to make sure the headstock sits firmly and precisely on the bed. If dirt gets trapped on this surface, the headstock would sit at an angle and the lathe would run a slight taper. The last most stubborn grime is lodged in the gap and needs the thin shim to help get it out. Now the bulk of the dirt has been shifted, I clean the bench down and wipe over the whole part with some clean WD-40 and a cloth. This is the handle pinion for advancing the headstock. Any dirt left on here would get into the headstock bore, which I'm anxious to avoid as it would interfere with the smooth spindle movement, and if the dirt was hard or abrasive, it could lead to wear and damage to the bore. To keep the chance of contamination down, it's best to keep the handle in the headstock even when there's no need to use it, as it keeps the risk of dirt getting in to a minimum. The last two large parts, the milling column and bracket for the headstock. There isn't as much grime on the bracket casting as the other parts, but there's a fairly stubborn layer of dried oil on this mating surface which needs careful removing. This flat surface mates against the underside of the headstock when it's being used as a spindle for milling and drilling in this alternative position. The mating surface and inner bore surface need to be in good condition to hold the headstock rigid when it's being used this way. The other two bores are for the headstock securing pin and the column. Some of the inner surfaces are tricky to clean completely. The column is the only part that's seriously corroded. Apart from the mounting at the bottom, the whole surface is covered in rust. I'll start out by seeing how much is superficial enough to come off with WD-40 and Scotch-Brite. More is coming off than I expected, and it looks like the rust is pretty superficial. The end where the column's been mounted is much less rusty and more grimy. This end of the column mounts into the lathe bed where the headstock would be. It's the same diameter as the headstock securing pin, but uses a different geometry to lock it into place. Instead of a rotationally symmetric taper, there's a single hole on one side, so the column is prevented from rotating as well as lifting out of place. There's grime embedded in the socket where the screw clamps the column in place, which is hard to get out. Making sure this is removed will help make the column more rigid when it's locked. After a good wipe down with a cotton rag, the column is looking much better than I expected. There's some pitting, but enough of the original metal surface seems to be there, and I think it should still be able to hold the headstock bracket true. The main parts of the lathe are now completely clean, and this video is quite long enough already. In the next part, I'll disassemble and clean the tailstock and the spindle, and try to sort out the most serious corrosion. Thanks for watching, take care, I love you all.